where these units come from, okay? And I think you can informally divide these units into three different situations here. So you've got what I call the classical era, when these units were first defined, and then what I call the industrial era, and then the modern era, the information era. Now you might say, well, hang on, I didn't sign up for a history degree. I don't really want to know about the history of these units. I just want to know what they are now. But it's important to know where these units came from so that we can understand the modern definitions of what these units are. Because if you just look at the modern definitions, you'd say, well, that seems really arbitrary. Why would you ever define a unit like that? But if you see where they come from, then it makes sense. So let's start with the meter. And this was kind of formally defined towards the end of the 1700s. Does anybody know how the meter was originally defined? So it was defined, have we got the answer there? It was defined in terms of the planet Earth. So it was the distance from the pole of the Earth to the equator divided by 10 million. So like I said, it's based on planet Earth. Once you've got a unit for length, you can define a unit for volume. And the unit that they use in this system is the litre. And once you've got a litre, you can then define mass. So the kilogram was originally defined as the mass of 1 litre of water. So it's a really nice way of defining mass, because you start with the length, and then you can construct a litre, and then anyone can fill up that litre with water, and then you've got yourself your very own kilogram. We've also got Celsius, and that was based on the boiling and the freezing temperature of water divided by 100. And that gives us the Celsius. And then the last unit from the kind of classical era, it's of course time. And time was originally defined by the rotation of the Earth. So the second, we had 60 seconds, 60 minutes, and 24 hours gives us 1 day. And that's where we got the second from. So those were the original definitions of the base units. The problem was, by the time you get into the industrial era and you want to start making trains and factories, these units, they're not consistent enough. They're not the same every time if you want to make a steam engine or something like that. So what we found, once we start to enter the industrial era, is that units were defined differently. So for the meter, instead of having this distance here, they just said, here's a platinum bar, and this platinum bar is 1 meter. That's the definition of a meter. So if you're twice as long as that, you're 2 meters. And then they did the same kind of idea with mass. So instead of saying the mass of a litre of water, they just said, well, here is a platinum cylinder, and this platinum cylinder is 1 kilogram. If you want to make your own kilogram, you've got to ask them very nicely if you can borrow theirs and calibrate your kilogram against them. And that's really the issue with this industrial era of units, that they're all based on specific objects. So if I said, look, I'd really like to do a physics lab for this module, can we borrow the standard meter for a bit and take some measures? You know, they're going to say no, thank you. And that's part of what motivated defining units in what I call the information era. So in this era, the modern era of units, all units are based on information. You can write down the definition of a unit based purely on information, and it doesn't rely on any physical objects. And it's a really important way of approaching units because it's reproducible. And it kind of gets back to what was so good about the classical era of units, that in principle anybody could reproduce them. So if we look at how the meter is defined now, it was changed in 1983 to be based on the speed of light. So we now define the speed of light as a fundamental fixed constant. And we say that the meter is how far light goes in 1 over the speed of light of a second. We take the similar kind of idea with other units. Now, I just want to emphasize with these other units, they're really kind of thorny, convoluted descriptions here. So I'm only really kind of showing them here just for kind of illustration. So please don't worry too much about all the details. I really just want to show them to kind of illustrate how we now define modern units. So with the kilogram, until very recently, the kilogram was just the mass of this platinum cylinder. Now the kilogram is defined as the particular mass, so that Planck's constant comes out at this exact value here. So we're going to learn about what Planck's constant is next semester. Let's not worry too much about all the details of this. All I'm saying for now is that we define mass in terms of an experiment that someone can perform, that in principle any of us could go and perform. And we set our mass so that Planck's constant comes out at this exact value, and then we've got ourselves our very own kilogram. And you might say, why that particular value? And it's so that we get back to the kilogram as originally defined there. So then the last unit that we need to think about for today is the second. So whereas it was originally based on the rotation of the Earth, it's now based on cesium atomic clocks. And it's specifically 9 billion and something periods of radiation from a specific isotope of cesium, cesium-133. And this is the point I want to emphasize with this, that you might say, well, why 9 billion, 192 million, the whole thing? Why not just, 10 billion? That would, make it a round number, make it a lot easier. And the reason is, with all of these units, to get back to this original definition, they have to match the original definition, but in a form that's going to be more precise and more reproducible.